Hello students, this is Mr. Fish. I'm back with you. Now we are going to continue with part 1 of chapter 2. Okay, so let me just get going quickly and to open what I need to open for you. Where are we now? Here we are. Okay, here we are. We are going to be looking at, as you can see there, chapter 2, and we are looking at motion in one dimension. What do we mean by that? Let's just make a short drawing quickly. If we speak about motion in one direction, then we are effectively just speaking about moving in one straight line. Okay, that doesn't look so straight, but that would effectively be one-dimensional motion. If you just move anywhere along a straight line. If you had to think of two dimensions, we call that the x-axis. Then this here would be the y-axis. And then any motion on this flat surface on a plane. Now, let's just draw it like a page. Any motion on this page here, that would be called a motion in two dimensions. Right. And if you were to think of, let me just get rid of these lines again. I'm going to draw this. Let's say there you have your x and you have the y like that there as on the page. So remember that is x. Sorry, I can't even type here properly. That is x. That is y. Remember these two are perpendicular to each other. And then you have another one going up there and down. And then that would be your z, where the z is also perpendicular to the y, and it is also perpendicular to the x. Right, so three mutually perpendicular axes, that would be three dimensions. Okay, we are dealing with, what did we say? Only with one-dimensional motion. Okay, so if we will just consider motion along one axis. So any motion that is going to take place again will be along that line, forwards or backwards, but only on that line. Right. So if that is your zero, then you can see if this is what we can call your zero position, then you can move forwards with respect to that zero position, or you can move backwards. So your value of x as on, let's call this a number line for the moment, or a line of real values, then x can be positive in that direction and it can be negative in that direction with respect to your reference position. But the motion is only along one line. Okay, and as you can see here, this will also be called linear motion. Now, just to take this whole thing further, they say here, the study of motion of an object without concern for what is causing the motion. In other words, a force or whatever, energy or whatever, all those without considering that, then we are talking about kinematics. Okay, so kinematics is only talking about motion, and that is what we are dealing with. Kinematics can be for two dimensions and for three-dimensional motion as well. But at the moment, again, as I said, we are only considering one-dimensional motion. Okay, everything on one straight line. Okay, when we are going to be looking at an object moving, for example, a car moving, or you or myself walking somewhere, it's a big object. We are not going to look at the object we are only going to think of a point, right? Okay, the objects that we're going to be looking at, the objects that are moving, just think of it as being a point. That is a bit of a simplification, but it will help us to better appreciate that for the moment. Okay, once you then to think of a car and all those things, and then it's a three-dimensional shape, it is a bit awkward because one finds that many other things will then have to be considered, right? So for us to be able to deal with one-dimensional motion, let's think of a point. And that point will just be moving forwards and backwards on that line. Okay, right. Okay, so let's continue. I think we did mention this in just now. Reference frame. Let's talk about position, velocity, and speed. First thing that they talk about here is your reference frame. And I see here you can actually see again, we have your number line. Right. Here, what do we see here? Here we have X measured in centimeters. SI units, obviously, this is not correct. That should actually be in meters. But anyway, it's not a problem. You can even have that in centimeters, kilometers, meters, whatever. Right. We know when we do calculations, it's best that your unit value for distance should be in meters. SI units, right? Okay. Now they say here, when describing the motion of an object, in other words, its position on this one-dimensional line, it is necessary to have a reference frame, right? Or they say, a coordinate system. Right, now the reference frame effectively is, let's call it a zero position. Let's say if we start moving from here and go to the right, then that is your reference frame. You start at zero and you move and you pick up distance, right, that way, or you move that way, right? Now you can see here, if this is your line, and towards the right we take as positive, then towards the left we can take as negative, as you can see here. Okay, so that is your reference position that we are talking, right? A zero position. Okay, position. For position, you need a reference frame, right? Your reference position. That's what they are talking about. Okay, right. Let's continue. Now here, let's start talking about position. If I were to look at this thing here, let's say you have that straight line again that we spoke about earlier. They say the position of an object is its distance from the reference point or from the origin, Right. You see here, for example, let's say we start moving, and at time equal to 0 seconds, my position is 0. In other words, we are at that position. We are at that position at time equal to 0. And then at a later time, 10 seconds later, we are at position 15. Right? So if we go from here, 0, positive 15, so it will be somewhere there. Okay, the dot will be there, and so on and so forth. Right? So let's just see what the table says for these different time intervals. These times 0, 10, at this time, right? At these moments. Those are the positions. Okay, well, what happened here? Let's see. In the positive direction to the right, it increased from 0 to 50, 45, 62. And from 62, it went back to 0 at 40 seconds. And then we went further to the left at 52, minus 52, minus 57, and then going to minus 40, which means from here, we went to the right again to get to that one. Okay. everything we must look at these things on this number line. Let's not call it the number line, let's call it the axis, right? The x-axis. Okay, right, if you were to draw a graph of this, so here's a graph, right? A plot, right? You plot these things, position with respect to time. So we'll have time on the horizontal axis and position on the vertical axis. So remember in what we said here, look at this drawing here, my x was horizontal line, but in the graph, my x is actually the vertical line. So the position is actually going this way now. And this one over here is just to show what happens to the position as time passes. The position is still just along this vertical line, but because of the time that passes, one finds that we get this here. So please, students, this is not actually the path followed by the object. The path followed is still along that line, just there. We need to appreciate this thing from graphs. But why does it look like this? Why does it have this shape? Is because at A, that is that position. At B, that is a position, remember there. Let's say you go up to that point there, but that is a position at this particular time. All right, so this is at 10 seconds, as you can see here. After 10 seconds, we reach position B. After 20 seconds, we reach position C. You see, from there to there to there to D, and then back to E, and then to F, and then to G, and then back to H. You see, the position is also still along a straight line. And we get this shape because of the time. Time continues from that point onwards. Time continues. So we end up with this graph. Okay. In real life, this is actually what we have. Can you see here? We position A, B, C, D, E, F, G, and back to H. Okay, so I just drew it like this here just to get a better idea. But remember, it should all be on one straight line. So from A to B to C to D. From D, we go back. You see the arrow, look at the arrow, back to E. And then we continue to F, and then to G, and then we turn back to get to H. Right, so all these positions that you have here are all on one straight line. Again, one dimensional motion. Okay, so remember that is how we appreciate position, right? Okay, according to this graph, everything happens for one dimensional motion. Everything happens along one straight line. Okay. Okay. You have heard of this word, displacement, at school. Remember how your teacher would have taught it to you at school is, if I have a certain position here, as you can see here, let's call it xi, initial position, and there's another one over there, xf, final position. And then imagine you follow this path. Oops, let's see, I shouldn't have gone to the next page. Let's do it over. Follow the path. There you are. Right. So you follow this path. Okay, from xi to xf. Right. Then your teacher would have told you at school is that the straight line from there to there, that is your displacement. And I remember I taught physics at school before, then we would have used the letter S to represent displacement. I don't know what letter you people used at school. I believe with the new syllabus, people might have changed symbols and things. Okay. But I remember I used the letter S to represent displacement when I was still at school, when I was there as a pupil, and when I taught at physical science at school, we used the letter S to represent displacement and D to represent distance. So this will be the distance, the actual path followed by the object, and then the straight line from the one position to the other one, the straight line, which is the shortest distance between 2 points, that will be a straight line. That would be called the displacement. Remember, we are talking about moving along one dimension. Now, can you understand the idea of a straight line? So when we are talking about displacement, we are not talking about actual paths that are followed. We are only talking about everything on a straight line, right? One-dimensional motion. Okay, so what do they say here? Let's continue. They say here, displacement is the change in position between 2 points in one dimension. That is along a straight line, right? Okay, so this will be displayed on an axis, like an x-axis, or a vertical axis, or a horizontal axis, or whatever. But all the positions will be along one straight line. Okay, so along that straight line, if I were to find out what the displacement is, we can call it delta x, and that would be your final position minus your initial position. So for this particular case here, I would have had a straight line this way, continuing there, that way, right? And this is not important to us now, right? But only the straight line. So if I have one position there and one position there, then along that straight line, you can determine the displacement from here to there, right? Where can I do it now? Let's do it on this side. I think I'll use a different color. That's a nice thing about this now, but just sorry, you people must bear with me. I am dealing with, I'm drawing with and doing everything with my mouse. What color can I use? That can be quite visible to you. Let's use the orange. Yeah, I can't see. Let me just get that out again. Let's start again. So from here, sorry, that there. You see, there's your xi and there's your xf. Then this distance from there to there, that will be your delta x. Okay, that will be your delta x. Okay. Here we are. Can you see that? Final position minus initial position. And that will be your displacement. Okay. All right. They mentioned some word here. Displacement is a vector. Right. It's a quantity, something that can be measured. So you can call it a vector quantity. We will actually be speaking about this in the next chapter. I found it unusual. I remember when I was at school and I was doing the subject and teaching the subject, we always spoke about units first, and then we spoke about vectors and scalars first, and then we went on to motion. But okay, let's go according to the textbook, and according to this textbook, these authors, they actually did motion first, right? And now they start speaking about vectors. But anyway, don't worry about it too much. We are going to be talking about vectors again later. I think what we just need to know about it for the moment is that a vector quantity is a quantity for which the magnitude and the direction, right? So the magnitude and the direction are important, right? And so the one way to indicate the direction is like that, to have an arrow, or alternatively, as you can see on this number line that we showed earlier, not sorry, I shouldn't say number line, the axis, from the reference position, you can have positive and negative values. So if you decide that this way to your right is positive, then these will be positive positions, and then from that one to the left, then will be negative positions. Okay. Yeah. Okay, so that is a vector quantity. You end up with a sign, positive or negative, or with a direction. Okay, just keep it positive and the negative. We might be dealing with that more often than we would be using with the directions. I think at school, you people use direction method quite a lot. Okay, right. Now, speaking about the other one again, distance. Right, speaking about this here, distance. There, as I mentioned to you people earlier, here, you can just throw in there we are. D for distance. Okay, so what is a distance? We say that is the actual distance traveled by an object. Right, so if you look at this thing here, this here is a distance traveled by the object. Right, the actual distance, so that becomes a displacement. But now let's think of this one over here. If I started at A, and then B, then C, then D, then back to E, and then F, then G, and then H. See how we moved? Right. What is the displacement between A and H? It is effectively just from there to there. Right. According to this formula, it will be minus, can you see here? If I have to use this formula over here, XF, so that would have been minus 40 and minus your initial position between A and H, we said, right? Minus 0. So my displacement, that in this case here is equal to minus 40. Okay, in this case, what was it? Centimeters or meters? I think it was meters. Let me just confirm that. Yeah, meters. There you can see. Okay, between A and H, the displacement is just minus 40 meters. So from your reference position, 40 to the left. Do you see that? So it's minus 40 in this case. Okay, so that is your displacement between those two. But what is your distance from A to H? So then we have to consider, we didn't just move from A straight to H. No, we move from A to B to C to D, E, F, G, and H. Right, so we must continue, actually take up that full distance, add everything up, irrespective of directions, right? Irrespective of direction. And then I just add all of that up, and that will become your distance. So you can even have a distance along a straight line, as you can just see there. This way, back that way, and back to this position. A total distance. Let's work it out together. 15 plus 45 is 60. That's plus 62. That is 122. And this is another 62 this way. So that will be 184. 184 coming this way, add another one there, that will be 236. 236, and am I right? I'm actually not. I'm making a mistake here. I can't add all of that up. It's just from here to there is 62. I'm sorry for that, students. From there to there. From here to there is 15. From there to there is not 45. So I can't add those two up, right? So from there to the furthest position is 62, right? 62. Yes, now we come back to this, another 62, tap back to E, and then we go that way. Then we go that way. The furthest distance is 75. So 62 and 62 is 124, 124 and 75. Right, and 75, how much will that become? That will be 197. 197, and then we go back from here to that position. So that is back how much? 35. Right. So 197 plus another 35. Right. I'm thinking here without a calculator. You use a calculator and get to your answer. Okay, so that would have been the full distance. Right? From there till there, back to that position, and back to 40. Okay. Okay, so that would have been your total distance. And they say there that distance is a scalar quantity, right? In other words, it will always be a positive value. Negatives don't come in to talking when we are talking about distance, right? There are no negatives, only positives. Like time, for example. Time is a scalar quantity. Time, you just add to time. You can't go back in time. Can any one of you go back in time? If you can, then you should become younger, isn't it? Doesn't make sense. Right. So time is a scalar. It's only positive. So distance is also always positive. You can't have negatives in distance. Right. Okay. But in displacement you can have. So that makes displacement a vector and distance is a scalar. And here, as you can see there, these things will be discussed in the next chapter. Okay, I think we're going to stop here. We'd stop there and continue in the next session when we're going to be talking about velocity, speed, and acceleration also. Thank you. Bye.